Gas chromatography works similar to other types of chromatography we've done before. The compounds being analyzed absorb on the stationary phase, usually a high boiling point polymer, and the mobile phase is an inert gas, generally helium, which transports or carries the compound through the column. In this lab, we will be separating butenes. You will need the following. You need to be careful with the concentrated acid. After handling the H2SO4, wash your hands with copious amounts of water. If you touch the acid, wash your hands immediately with lots of water. This is how you set the apparatus to collect the butenes. First, wrap the tube around the needle. Do not uncap the needle. Be patient. It might take some maneuver to get the tube around the needle. If there is a hole in your tube, replace it. We don't want the gas escaping. Fill a 5 ml conical vial and a 100 ml beaker with water. Place the other side of the tube inside of the 5 ml conical vial filled with water. Weigh 0.2 grams of 2-butanol. 0.2 grams of butanol is about 10 drops. Add your spin vane. Add 10 to 11 drops of H2SO4 to your conical vial with your 2-butanol and spin vane in the hood. The reaction will start as soon as you mix the H2SO4 and the 2-butanol, so make sure to cover your conical vial fast. Don't forget to wrap the rubber around the conical vial. This will prevent gas from escaping. Place the conical vial filled with water inside the beaker that is filled with water as well. We don't want water to leave the conical vial, so you have to be fast. This will make a water trap and will gather all the butenes inside the conical vial. Uncap the needle and stick it in your reaction vial. Make sure the needle doesn't touch your liquids. Place your reaction vial on the hot plate and turn on the stir and heat dials. This is how your apparatus should look like. Make sure the tube is not touching the hot plate. Since we are working with concentrated sulfuric acid, make sure to secure our apparatus with a clamp. You should observe the bubbling of gas into the collection vial. Since the first gas that enters that collection vial is just the air in the plastic tubing, let the system bubble through even after the collection vial is full to concentrate the vial with butenes. About this time, the reaction vial should turn a dark color and eventually gas evolution will slow down. When this happens, turn off the heat and stir dials and remove the tube from the conical vial that contains the butenes. Cap the collection vial. Note that this must be done while the vial is still under water. When cleaning, be cautious. Remember that we used concentrated sulfuric acid. When getting rid of the needle, you need to do the following. Remove the tube. Carefully remove the needle from the conical vial and place needle in a beaker. To avoid accidentally stabbing yourself, do not cap the needle. Throw the needle in the correct container. Do not close the container. The professor or TA will be there with you when you use the GC instrument, so if you have any questions, they can help you. First, make sure that the voltage in the GC is at 100 and that the gas pressure is not at 0. This should already be set for you, but if for some reason it's not set like that, do not change anything. Please inform the TA or professor and they will fix it for you. To extract the gas from your vial, you will use a special syringe. Insert the syringe in your vial. Again, make sure not to touch the liquid. Extract 1 milliliter of gas and place the needle in one of the ports of the GC labeled A or B. Inject the sample and then hit the start button. Now, we just have to wait for the GC to do its part. This is what you will see when the gas has gone through the GC instrument. It will automatically calculate the percentage of each gas. However,
This includes the air percentage, and we don't want the air to be calculated in our percentages. In order to calculate the real percentage of our three products, we need to scale down the percentage. Well, this is how you do it. We add the areas of our three products. This number is our new total area. Now, in order to get the percentage of our three products, we need to multiply one of the areas times 100, and then we divide it by the new area. Now you do this for the rest of the products.
As we can see, trans 2-butene has the highest percentage because it's the most stable.